no further ado, we're lucky to have Darryl Boyce with us, our distinguished lecturer, to go over carbon emissions and receiving enhanced indoor environmental buildings. So, Darryl, you have quite a long list of achievements with ASHRAE. So I could go through them all, but it took us about 15 minutes to get here, and it probably was about 10 minutes of you going through most of how many there were. So we're very lucky to have Darryl with us. He's very experienced and he knows his stuff. So thank you very much for coming to our chapter and spending your time with us. So Darryl Boyce.
You still hear me on this? Yeah. Okay, good. Okay, let's
Or you can blame that on me too.
I can blame something?
Blame that on me as well.
Come on. Okay. So what we're going to do is my presentation really focuses around reducing carbon emissions and achieving at the same time improved indoor environmental environment in existing buildings. Well, it could also be done in new buildings as well. But anyway, with the description of the presentation really deals with a roadmap of how you could go about looking at an existing building and saying, well, we want to decarbonize this building, but what are we going to do that's going to actually enhance its indoor environment for the people that live, work, and sometimes play in these buildings? And so I'm going to talk a little bit about the tools, also talk about some evaluation tools that we've been looking at society in terms of looking, how do we evaluate how a building is operating and functioning effectively? And we'll also look into the work that ASHRAE is doing in the decarbonization of the built environment area. Now, it's a fairly high level. I'm going to hit a number of things at a relatively high level. But hopefully, if there's more questions you have about any of these, just send me an email and I'll dig into giving you a little more background on them if that's helpful to you. So we're going to talk about some challenges in the built environment in terms of existing buildings, ASHRAE initiatives, as I talked about. The role of intelligent buildings, I'm going to touch on that. Evaluating the opportunities, capital plan, prioritization, some energy reduction and renewal, and a Carleton University business case, some of the things we did at Carleton University, and then wrap up with some lessons learned about what you do in the areas. So some very common challenges in the built environment is rising cost of energy. You start to put carbon emission on that, it's going up even faster. Requirements by the governments all across Canada in particular, to reduce carbon emissions, the need to improve the indoor environment. I mean, if one thing we learned from the pandemic is the importance of that quality of indoor environment for our occupants. Aging infrastructure, most of the buildings we have today will be around in 50 years. They're going to age between now, if they haven't already, and the growing deferred maintenance backlog that comes along with the aging infrastructure. And then if you have a portfolio of buildings, so you have a group of buildings, maybe 10, 12, 15, 44, you really want to understand what is this facility's portfolio. So what do we have? What are they in terms of condition functionally and physically? We want to understand what actions are required to support the organizational mission. I mean, after all, that's what the buildings support, is the organization. How should actions be prioritized to support that mission? And what are the costs? How can we adapt to changing requirements like carbon taxes? How can we make the case for obtaining funding? And then how do we manage that funding? Now I'm going to switch a little bit to ASHRAE, what we're doing in the area of decarbonization. So if you look at ASHRAE, since the mid-70s, ASHRAE has been very focused on energy use, effective use of energy, and energy reductions were a priority at the level that they can be done without negatively impacting the indoor environment. So then the greenhouse gas emissions became a major focus in the last few years. And so the society decided to just take a position on that. And so the position is that eliminating greenhouse gas emissions from the built environment is essential to address climate change. So ASHRAE's taken a stand in this area. And so the decarbonization objective really is to reduce whole life greenhouse gases in the atmosphere as measured by CO2 equivalents. So whole life carbon includes operational and embodied carbon. And building decarbonization strategies must consider healthy, safe, comfortable environments, environmental and social impacts, sustainability, and economics. So these are the things that are sort of the box within which we have to work in terms of our decarbonization. So we created a task force to actually work in this area. This year we have a task force that's working on sort of products and initiatives to decarbonize the built environment. The year before we had a task force that was working on the definitions of decarbonization and which ASHRAE's role in this. So now we have a task force that's expediting, ensuring, collaborating, and coordinating to get the job done. And they've decided to focus on 4 key areas. So standards, education, technical tools, and a position document for society to use in terms of communicating their position on decarbonization of the built environment. And this is all contained in a knowledge resource hub that can be located on the ASHRAE website. So they've been working to put this all together. So some key ASHRAE building decarbonization resources are, of course, Standard 100, energy efficiency in existing buildings, Standard 211, commercial building audits. And these have all been tailored to start to include carbon emissions as one of the things that's actually measured and evaluated in these programs. And these can actually be tailored to whatever jurisdiction would like to start to adopt these. Then they also provide technical support and training and briefing specific to needs and non-commercial, apolitical positions. These are technical positions, not positions that one political party could use against another. And that's really the fundamental premise of it all. And then, of course, there's training and education programs. So what have they done? So far, they put out a building performance standard, and this was released in January 2023. And they just released recently this fall a grid interactive buildings guideline. And so these are the things, and so they're working on TM65 for North America. And if you don't know what that is, that's actually the embodied carbon in the actual products that are into the HVAC and R systems. So that should be out later this fall. Whole life carbon is something that's also being worked on for a fall release. And then decarbonizing hospital buildings has been a focus, and that should be out in the spring. And then building decarbonization retrofits will be a big one because that applies to just so many buildings in our portfolios. And then finally, a guide on effective utilization of heat pumps in decarbonization. So then I want to talk a little bit about analytics and smart buildings and how they play a role. The use of analytics in the built environment creates a shift from actually sort of ad hoc actions to help a building operate properly to much more organized actions, because you're using data from the systems to actually help you analyze what is functioning properly or as designed or as expected versus what is not. And it allows you to focus your time and energy on the things that really matter. I don't know how many of you have been in building operations, and the building automation systems put out more alarms than anybody could ever respond to. And I found in our operators at the university, all they do is sort of silence them. So they don't really know which ones are important because there's so many of them. Well, analytics is that tool that helps you get to the bottom of what is important in those alarms, so you can actually respond effectively. And analytics also makes it possible to track and verify previously implemented energy savings projects, and actually verify they've actually achieved the goals and objectives that you intended. Which then we do a shift to smart buildings. And analytics are a part of it, but there's more than just analytics in a smart building. And that's about effectively maximizing and assessing sustainability and effective building operations in a smart building requires actionable insights. So smart buildings actually collect a lot of data. They don't just collect data from your building automation system. It could be from your lighting control system, from your scheduling system, from systems that actually count the number of people in the building, so occupancy counters. And they bring all that data together, and then they start to analyze that and action how to operate the building effectively given all this information that they have. So a smart building is where we're headed. It's not easy. I can tell you a little bit about the ASHRAE headquarters building, which we renovated a 1970s building to current technology. And we have a robust IT network. We have systems that can connect to the network. So theoretically, we have a great data collection methodology, but some of the systems don't connect very well. And that's a problem. So we're trying to work all these things out so we can have that useful data come into a central area, analytics and some other smart technology tools. Artificial intelligence should help us operate the building smart. Smart buildings generate data. In turn, we need that data to optimize functionality, and this will deliver better indoor air quality and effective use of energy and carbon. So if you look at the building energy analytics tool, we're really talking about transforming your built environment and analyzing and creating realistic actions. So what's all this going to do? Well, we hope it's going to increase energy efficiency and reduce carbon emissions. We hope it's going to improve occupant comfort because it's going to give us information about occupants. You can even start to collect data from the occupants about how comfortable they are, how they feel. They're going to reduce maintenance costs, or most likely shift the maintenance to the right areas, not necessarily reduce it. And prolong equipment life and capital plan upgrades, so enhance your ability to run those capital plan upgrades longer. So analytics fundamentally works as a system of collecting data from all these systems, from the chillers, from elevators, from your light network controllers. Typically uses some form of a device to collect that data and transfer it into the cloud. And once it's into the cloud, somewhere up there in those clouds, it actually transfers into a server group which analyzes the data, runs the algorithms on it, and then eventually gives you out useful information out the other end. So analytics in themselves will say there's something wrong with that system or the way it's operating. But it usually does not tell you what to do about making it operate more appropriately. So that's kind of the next level of where the analytics needs to go. And I will say that the ASHRAE headquarters building is doing a pilot on that. So we have a analytics software that's been donated to the building, and we're going to upgrade it so that it'll actually tell us what to do with the building automation system controls to make the building operate more effectively. And apparently at some point we can actually flick a switch and it'll automatically adjust the building automation controls, but we're going to give it a trial run before we do that. One thing about Atlanta, you don't have to worry about freezing the building up. So I say, well, what the heck, let's do it. So now I'm going to shift again to facilities and their conditions. So facility condition assessment program. This is a program that was adopted by the universities and colleges in Ontario. And so the Ontario University Vice Presidents, with support from the government agency that oversees the universities and colleges, initiated this program in 1999, and it was really to provide consistent, comprehensive data to the universities, to the presidents of the universities, governing bodies, and the government about the condition of the facilities, and leverage best practice facilities management tools for each institution to use to evaluate their buildings and develop a strategy to improve the condition of the buildings to serve the goals and objectives of the university. So the Ontario University System, SCAP, collected comprehensive facilities data on each building, provided best practice facility management tools, and we did contract, the entire system contract with one service provider for the software to provide central database and provide facilities officers with built-in RS means to actually estimate the work to be done. So it was a major initiative, and the university is committed to do 20% of their campus every year. So on a 5-year cycle, each building was audited for its condition. So once you had that data, we say, okay, so now what are we going to do with it? So we developed a strategy about sort of facts-based prioritization for capital plans. And really, we set priorities at the requirement level. The requirement level could be, well, we have a chiller that needs to be replaced because it's getting past its useful life. And so we would look at all those requirements, say, okay, how does this requirement impact on occupant experience? Priority number one. Impact on strategic objectives, return on investment, level of risk, or organizational key objectives. So with that, we had a numerical sort of rating methodology that went along with that, and it allowed us to then start to sort these initiatives by top priority for the institution. And it gave us a really good way of focusing on the right building at the right time and the right system. Now I'm going to shift a little bit to how to evaluate energy and carbon emissions. Well, and I'm going to look at 4 different methodologies, at a very high level though. First of all, it's ASHRAE's Building EQ. And I'll say one thing, as ASHRAE developed this, it was one of the things that ASHRAE did that was really about building owner operators. This was a tool for them to use in how they assess how well their building is functioning and what opportunities there are to improve its operations and functions. So, and then I'm going to talk a little bit about Green Globe's existing building. And that's a system that we actually had used at Carleton. I'll mention LEED E-Bomb. Don't have a lot of information on that because they've done some major modifications to that system. And I'll talk about BOMA 360. And I could say that Green Globe's existing building and BOMA 360 have all donated their system to our headquarters building to be used to evaluate the headquarters building, so that we have a chance to actually demonstrate how well they give us good information about how we can improve the building for its occupants and for its operation. So Building EQ is really a free web-based portal, benchmarks energy performance, and now includes, in the last 2 years, we've included operational carbon metrics. And it's really connected to an ASHRAE Level 1 energy audit. And that's important because not only do you understand how well your building's doing existing, but you have opportunities to improve that come out of that energy audit. And it provides data to improve energy performance. And as a result, typically reduce carbon emissions. So the in-operation assessment uses metered energy data, reflects on how the building has been designed, how it's being used and operated. It's actually the most common application. We have another Building EQ for building design, not used very often, but this is the one that's used most often and has been used by a number of universities in North America. And it has a rating from 0, which is a net zero building, to 200, which is a very inefficient building. So that's the rating system. Allows for tracking of improvements and comparing building to itself over time. So it's a tool to say, well, we measured our rating this year, and now we're going to do it again next year and see how we're going. So has the way we operated the building deteriorated, or have these improvements we made a difference? And as I said, it provides a level 1 energy audit, which absolutely complies with our ASHRAE standard 211 on energy audits. And the site visit is required for the collection of data. So we actually have to have somebody go to a site that's qualified to do an audit. Building EQ delivers a level 1 energy audit report out of the end of it, and customers get an understanding of how the building ranks against similar buildings and their initial evaluation on how to improve the building. And then there's building EQ spreadsheets that can be used and modified so that you can use them regularly for your buildings. So it's really about how good is my building? You ask the question, you get an energy bills, you do a walkthrough, enter data into the portal, and then you get a score, and then you go a couple of methods. You can celebrate this through an ASHRAE Building EQ award, a label award, or if you just want the information to improve your building, you can just take that information and start discussions around what have we learned from this energy audit and how do we actually improve the building. So there's two ways you can do it. One costs you a little bit of money and the other doesn't. So now I'll move on to Green Globe's existing building. So this methodology establishes a baseline guide for improvement, assesses opportunities for energy savings, reduce environmental impact and lower maintenance costs, and also establishes a baseline by importing energy, water, emissions, and waste data to measure progress and compare performance. So it goes a little beyond the building EQ in terms it also deals with waste and other environmental issues that you might have in your building. And you compare Green Globe's and utility consumption performance among portfolio properties, and which was really useful, and I'll show you in a little bit some of the data that came out of our system at Carleton. So you can look at the different buildings and see how well they're performing in this portfolio. You can clone questionnaires for use for substance certification programs in similar buildings, so it can be simplified. Lead operations and maintenance. Again, this one is the revisions to it have been fairly new, and I haven't had really a chance to have a good look at it. But they say it focuses on performance data, allowing projects to earn lead points through building performance monitoring. And then with this data-driven pathways allow projects to measure, share, and learn from the performance data on an ongoing basis. I do know that originally it wasn't really an ongoing performance tool, but they say it is now. And these methodologies will continue to be refined as more projects participate. So there's a lack of participants in this program to date. And finally, BOMA 360. As I said, we've had this donated as well to our headquarters building. And it's a program sponsored by BOMA International, evaluates the building against industry best practices in 6 major areas: building operations and maintenance, life safety, security, risk management, training, education, energy, environmental sustainability, and tenant relations, community involvement. Again, it goes much farther down the list of measures for the buildings than building EQ. But again, if you want to look at just focus on reducing energy and also reducing carbon emissions, the building EQ is a good way to go. So now a little bit about Carleton University and what we learned from our experiences there. The university was founded in 1942, so it's not really an old university. Located in Ottawa, 44 buildings, roughly speaking. I think there's one more now. 62 acres, 35,000 students. Building design rating system that we employed was Green Globes for designing buildings. And building operations rating system we employed was Green Globes for rating it. And building condition was a company called VFA. And that was the company that did the entire university and college sector. Now, we're pretty proud of the university in that we'd really started energy management, sustainability, and the foundation was set in the mid-90s. And the biggest thing we did back then, there's a lot of dumb things we did, but the best thing we did at that time was campus-wide energy metering systems. So we metered steam, we metered water, we metered electricity in every building. Typically you get electricity in some form or other, but we got steam, chill water, and electricity. So we had pretty comprehensive metering capacity. Problem was we didn't use it for many years, so it wasn't actually, it wasn't properly set up. So, but we had the meter so we could do that. But since then, many energy reduction initiatives had been implemented. And in 2006, though, we initiated a formal sustainability and energy evaluation by selecting the Green Globes. 2009, we piloted a campus sustainability rating system, and it looked at all those other things, you know, the environmental impact, the waste reduction, all those things. And we could look building by building and rate it, but we could also rate the campus. And then we decided we really needed a sustainability strategic plan. So we completed that in 2012. And really the fundamentals of that was that we were going to build or renovate facilities to meet current green building standards. Not necessarily get a plaque, but we're going to focus on the green building standards. Act as a physical tool for education for the campus and for the community. Continue to improve the indoor teaching, research, and work environments, reduce greenhouse gas emissions, and establish a roadmap for continuous improvement. So it was quite a major commitment. And so what we did then is we did the energy master plan following out of the sustainability master plan, and that happened in 2014. And we started off by auditing 19 of our buildings. Identified potential savings around 6 million kilowatts hours per year. Recommended measures were mechanical, lighting, operational, building envelope initiatives. And then the master plan document provides an inventory of existing energy and water use, provides baseline for future decisions. And that baseline is important. You have to know where you are before you start making changes so you know how well you're doing. And identified opportunities for campus energy water conservation. And also we had the ability with this plan to then look at future growth of the campus and say, how many more buildings can we install before we have to deal with increasing our energy capacity, either electrical or in this case steam. So then we got the process of really opportunity evaluation. And again, the first step were those energy audits. And the first energy audits were important to develop potential business case for projects in each building. And, but not all energy audits ended up in an energy project. Some of those, we had so much deferred maintenance in the building, we just made it a renewal project and not an energy reduction project. The difference is renewal is you spend the money, but you don't really get it back ever. And the energy projects, you spend the money and there's a payback in some period of time. And then the CTTC and library buildings did not fit the energy recovery, the financial recovery business case. So this gives you an idea of what we had in the campus. So this talks about greenhouse gas emissions. And one thing that wouldn't surprise you is this first, the tallest one here is the maintenance building. Well, that had the boilers and for the campus. So greenhouse gas emissions were quite high in that. But the other thing that kind of was a bit strange is that where's the well, and they were higher than the these are the athletics facilities. These are the science labs. Those are the residence buildings, and finally the athletics facilities. And the one on the end is actually the ice house. But then if you look at the energy performance, it turns out the building, the maintenance building, isn't the highest ranked. It's one of our lab buildings. And so our lab buildings are the largest energy users. So now you have to say, okay, where are we going to invest our money in terms of payback? Is it the ones that we can reduce the energy on most appropriately, get a payback on it, or do we go after the CO2 emissions? But again, you can't really make effective decisions unless you have this analysis as a baseline. So here we had all this opportunity. And we did have an energy management group in our department, but it was like 2 people. And we had a very aggressive idea of what we wanted to do. So we decided to do an energy services contract as a business partner. Now, but we had an unusual methodology because we wanted to do a building at a time, not the entire campus. So we went out with an RFP to select an energy services company and gave them 1 building to work on as a pilot. And then they did a detailed building energy audit, an indoor air quality improvement audit, and added in the renewal opportunities. So it was like, here's the building, we want to reduce the energy, but we want to improve the indoor environment, and we want to renew the things that need to be renewed in the building. So the Energy Services Program reviewed opportunities, selected a package for implementation. So the energy company would typically go for the energy things that are going to give a shorter payback. So they came up with a recommendation, and then we said, well, no, but we want to add this, 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 and this into it because we need to have those things done. And then once that was done, they actually installed sub-metering to ensure that we were measuring the building energy use and not a production use. Now you say, what production? You're a university. Well, the building we picked actually had a print shop that printed materials for other people outside the university on a business basis. So we didn't want the energy use in the building to be affected by the print shop that could be making a bunch this month and maybe less next month. We wanted to communicate with the occupants. It was very important that we keep the occupants informed. We installed pilot installations of proposed products and had them tested by the occupants, particularly low flow issues in the washrooms. And then the investment in that pilot was $1.3 million with a simple payback of 11 years and a reduction of 250 tons of CO2 emissions. So 11 years. A lot of businesses or organizations would say that's way too long. But you have to look at what it's doing, right? So this gives you an idea. This 100,000 square foot building, 1.3 million, I said. And the initiatives were lighting retrofit. And what had happened in the 90s was to reduce the energy, they took out every second fixture. Right? That's what you did. So now there's this lighting level in the building that's just not all that good. So the lighting retrofit put it in LEDs in every fixture. And we used less energy out of the lighting than we did before. But that was an initiative to improve that indoor environment. Water fixture retrofit. This building had actually pneumatic controls. That's how old it was. We converted that to DDC controls. But they were going to, we had these fan coil units along the perimeter. And they said, oh yeah, we should put electric valves on there. And I said, well, wait a minute, we got pneumatic valves, and they've been like working for a long time. And why don't we check them out first? And they did a check on all these pneumatic valves, and the valves themselves were fine. It was the control that wasn't any good. So what they did is they put a E to P a converter on there so the pneumatic air would come out and drive the valve, but it was an electronic signal that told it what to do. And that worked just fine. Replaced ventilation control box, sealed the building envelope, and implemented power saving options, computer shutdown, central printing, and power bars. So these were the things we did. The ventilation rates were improved. The ventilation boxes were actually working. And what we did all through this was employee communication. So we provided information to the building occupants, but not just that, to the entire community around, and which alleviated feelings of uncertainty. They knew what was going on. They knew our commitment to a better environment at the end, communicated implementation process, and ongoing conservation measures maximize the results because they understood what their role was in all this. And then public relations to the community was addressing needed renewal of our campus facilities through a fiscally and environmentally responsible program. And when we were all done with that building, the people were pleased. We got all sorts of replies from them about how great it was now that the noise levels were reduced, the ventilation rates felt better, and the lighting was a major improvement. So that's a program that we put on that really impacted that building, and then we moved to other buildings along the way. So decarbonization challenges, retrofit challenges, and this really focuses on institutional. Many institutions have considerable investments in their central hydronic systems. Maybe it's steam, central heating plant. It might be high temperature hot water. Hydronic heating system pipe sizes, coil capacities can be a real problem in converting them to low temperature or heat pump applications. So determining the best sequence of decarbonization strategy is important. Many heating systems are grossly oversized, though. That's that conservative nature of sizing heating systems. And part of it really is you're not really sure if you're going to make an addition to the building or how the building is going to be used in a few years, but they're oversized. And then heat pump technology requires considerably more space than condensing boilers. So there might be a room issue. And refrigerant global warming potential and system size really does matter in these areas. So there are opportunities in retrofit opportunities, and we can reduce operating costs by using deep energy retrofits to reduce loads. And we can solve other building problems like deferred maintenance, indoor air quality issues with deep energy retrofits, as we saw in the example from Carleton. Heat pump size to meet the majority of heating load profiles can obtain a proper life cost return on investment. And it says majority of heating loads. So there's a message in that. And money for maintenance, repair, refreshing provides opportunities to reduce energy and at the same time. So rather than renewing with the same system. So now I'm not going to go really into the detail of this so much, but this is sort of a decarbonization prioritization. And so what we're saying here is that retro-commissioning is really the best first step. And so you can look at retro-commissioning of your envelope, your lighting, your HVAC, air, water, and whatever else is an energy-consuming part. So once you've done that, then energy efficiency measures are our next good step to reduce carbon, reduce the energy, and typically, even if it's electrical energy, it's reducing carbon to some extent somewhere. And again, you look at the same things, except you do also building automation. So once you've done all that, then you can do your deep energy retrofits, which you might want to change a whole system in the building. And then you might want to electrify, and you can do HVAC, electrification, hot water cooking, energy storage, metering and controls. And then finally, on-site renewal would be the last step. And I can say that when we took the ASHRAE headquarters building that we bought, the 1970s building, our goal and objective in setting the design parameters for that building was to be net zero ready. So what's that mean? It means that we want to have a great indoor environment for the people that work in the building or visit the building. And we want to use as little energy as we can to provide that environment. And we accomplished that. And then we were actually able to put in a reasonable amount of photovoltaics to actually get us to what will be net zero. I found this to be an interesting slide because it talks about the electrical distribution systems in various countries. And you can see it's compared, Canada has actually got pretty clean energy in the electrical distribution system on average. Now there's some outliers with that, but then you have places like British Columbia and Quebec that are very clean energy, so it brings our average down. But we don't have as far to go on electricity today in terms of greening it. But as we up our use of electricity, it's going to be an interesting journey to see where we end up in terms of how do we provide that additional energy. Do we have green sources to do it? Are they economically viable? I can say that it takes a long time to build another nuclear reactor. It takes a long time to build another hydroelectric dam. Wind, solar, they all have their interesting dilemmas, but you can even see that our electricity is not as clean in the last year as it was the year before, but it needs to be taken into account. And then there's just a little clip here on CO2 emissions. If you have a 80% boiler versus a 70% boiler. So lessons learned from, well, and this was really lessons learned from our decarbonization conference that was held in October in Washington area. All greenhouse gas emissions matter, whether it be operational, embodied, or refrigerant. They all matter. And decarbonization retrofits must reduce whole life greenhouse gas emissions. So when you retrofit, you've got to be worried about what is the embodied carbon in the equipment that's replacing the equipment that you already have. And you need to determine actual peak heating loads and load profiles when decarbonizing existing heating systems, because generally speaking, they're oversized. So never replace the same size equipment without first determining actual needs for the existing building. And there is a paradigm shift in the cost effectiveness of heat recovery technologies with all electric buildings. Building envelope and heat recovery options that were not cost effective in the past with boilers are now often economical with electrification retrofits. Thermal storage is going to be our ally, technical and economical, when providing heating solutions with hydronic heat pumps. Turn down ratios still matter in heating systems. So that bridging of the load through storage is going to be very important. And this is a little hint when you're designing, use minimum two-row heat coils, even if you're using steam or high temperature hot water when designing thermal reheat systems today, because you'll need that when you go to low temperature hot water to improve energy efficiency, whether it be a low temperature distribution system or heat pump technology. And don't be afraid of partial decarbonization strategies for meeting life cycle cost requirements. So don't be afraid to do partial, because you can't really afford in a life cycle cost to do the total net zero, because an 80% greenhouse gas emission reduction is better than no reduction. A 60% is better. A 50% is better. Whole life carbon emissions, we need to ask ourselves if we are reducing the whole life carbon emissions of a building or system we choose when we choose a decarbonization retrofit solution. We need to be concerned about all carbon emissions, operational embodied, including refrigerants, and ASHRAE standard 228 shows us how to calculate annual refrigerant emission losses when considering alternatives. And finally, we can all make a difference. We can start a whole life low carbon reduction discussion in all our buildings, whether it be one in design or the existing buildings today, and really make a difference for tomorrow.